All right. Hello, everyone. Let's finish some of these notes and then get on to 2.2. Yeah, unfortunately, can't be there to finish it out with you. So, pretty important lesson coming up as well. So, fill out the rest of this without, let me pause the video to kind of recap what we did yesterday. Just to kind of define what is parallel, perpendicular, skew to CD. And then they have another thing about the plane. That's only one answer. Try to fill as many of these answers as you can possible, so then you can kind of get a feel for what directions you can go in. All right, pause it. Did you pause it? And then you can see the answers. All right, I'll throw the answers on here, but hopefully you paused it before I showed these. All right, plane EFG. That's that one. I want a parallel plane. That's like the floor and the ceiling we talked about. So I'd say that top one. So I'd say plane, and then any combination of A, B, C, D. So I'll just pick A, B, C. That's fine. If you said like D, A, B, or I don't know, whatever, that works too. All right, what is parallel? I would say this one, AB, GH, and EF. If you switch those letters, that's fine. But all those pieces, I'm just going to put segments since they are segments. Those are all parallel. They're going forward and back, so it works out. EF, nice. Let's see. What about, I'll do perpendicular next, since we did that second. That would be anything that intersects. Since it's a cube, they intersect at a right angle always. But just remember, perpendicular means it has to be 90. So we're going to assume that this is a cube, which means that they're all 90. So I'd say those two, DA and CB. DA, CB. There's some more. Don't worry. I'd say DE and CF. Yeah, up and down, and then anything kind of intersecting that line would have been probably good, especially since it's a cube. Skew. Let's see. Sure. Skew, remember, means doesn't touch and goes in the opposite direction. So, like, this is not skew, even though it's, like, not going to touch it and it's on the other end. That would not work. That's parallel. We just showed that a moment ago. It still goes forward and back. So, like, I need something not touching and not parallel to it. So AH sounds great. There's a lot of options for this, actually. So you got BG, boys. BG, boys. Not that one. You could say, I'm going to erase this one, EH and FG. And then you had this like other one here, or AG. That would work. I feel like there might have been another. No, I think I got them. It's pretty good. Yeah, a couple more. Skew. Nope, can't think of any. Great. All right. But those are all the pieces you could have had. You only needed one maybe, but good to know where they all are. All right, actually try this. I don't know if you tried this or not, but try that as well. Maybe pause the video. It's pretty easy, and it's a little ACT idea. So try it and then see if you get the same thing. Pause. Okay, let's do it. Perpendicular. Okay, so D is a point on AB and CD that is perpendicular to AB. So you know these are 90. Immediately, I would just try to draw in the picture or just kind of keep note of that, which is the best conclusion. CD bisects AB. Well, bisect means cut in half. 1, it doesn't look cut in half. But then 2, that's a bad reason. So 2, I would say that that's not a definition of bisect of, like, all we know is that it's perpendicular, so all we know that that's 90. I don't know. It could have been 90 over here. That doesn't mean it bisects, so that would be a bad answer. And then if you're looking at the other answers, you can see that it's talking about lengths and stuff like that. Perpendicular has nothing to do with lengths, so I would immediately get rid of anything regarding length. And then your last two options are that the two angles are congruent or the angle is larger than the other. Well, clearly they're both 90, so yeah, they're really just testing you to see if you know what perpendicular means. And we do know what it means. It means 90 degrees. Two lines that intersect at a 90-degree angle. Cool. All right, let's move on. Don't forget to do some of this practice. This is good. I really do. These are okay. These are pretty good for just talking about it. Drawing it actually would be pretty good. But actually this page seems pretty good. I would say that's your best ticket item along with this, but anyways. That practice is not maybe as important, but definitely just a recap on the stuff we've done. I'd say anything beyond this practice is a lot more important. Okay, we're gonna talk about when not parallel lines. I know this is parallel lines, but man, we just need to talk about if you have two lines and you have a third line intersecting those two lines, that's what we call a transversal. Transversal is a line that intersects two lines. So here's your transversal here. I'll put a T by it. Transversal, transversal, transversal. This line is the important one. It's cutting the stuff in half. Or not, sorry, try that again. It is not cutting stuff in half. It is just splitting, it's just intersecting both of the lines. That's really all it is. Now that intersection of the transversal, pretty important because it creates these relationships that we're going to talk about pretty soon that are really important. And how do we name some of the angles in relation to each other at the two intersection points? So wherever they intersect is kind of their important pieces to our relationships, because at each red dot it creates four other angles. 1, 2, 3, 4. And then technically there's 8 because there's 4 more here. So this is not going to seem important now, but what we're going to do, it will be important when these are parallel, but they're not parallel here clearly, right? They need to be facing the same direction. They're definitely not. They're just pointing in a similar direction, but they'll intersect probably here or something, right? What we're going to do is we're going to name the type of angles that are at these intersections in relation to each other. So the first example is our corresponding angles. Corresponding means matching. They are in the same upper right-hand corner. You have many corresponding angles. You could have these corresponding angles in the top left corner. I don't know, I'm just putting different colors and markers so that you can kind of distinguish between these things. I mean, you can have it in the bottom right, you can have it then in the bottom left, but like, I don't know what would be the best for you to describe, because if you just have all these little, all 4, that's kind of hard to like see what you're doing. If you need all 4, that's fine. I would also maybe copy the picture a little bit since there are so many and just do one set. And then if you want to have the rest of it, that's fine. But just make sure you know that, like, where they're located. If you need colors, this is a great day for some colors. If you're a color fiend. I don't think I have colors to give you, unfortunately. Okay, let's keep it going. Hopefully I'm still recording here. Yeah, we're good. All right. Alter interior angles. Those are on the inside that are alternating or switching. So I would say this is a great set of alternate interior angles. And vice versa, you can go on the other side, but I don't think you should write both of them, or you could. I think one is good enough, but if you like both and just put 2 arcs, that's fine too. Okay, and another set is going to be alternate exterior angles. That's on the outside. So same thing. You're on the outside. When I say inside or outside, I mean inside or outside of this like piece between the 2 lines in question compared to the transversal. So we're talking inside, right? Inside for this one. But now we're talking outside of those lines. So anywhere up here or down here. So these are on the outside, right? And your other set would be here and here. They're switching and they're on the outside. And the goal of the end, oh, let's try that again. Let's just do the rest of these before I say that. Consecutive interior, or we're going to call it same side interior. They're going to be on the same side on the inside, so they're not going to switch, not alternate. You're going to want to write this down because I think it'll show up more like this than consecutive interior anyway. So same side would be boom, but yeah, I'll just put that, that's fine. Those 2 would be consecutive interior, and then the other side would be these 2. So those are all your, same side interior angles. The goal at the end of the day is to be able to name, if you see like the pairing of angles, is to be able to name them with the appropriate relationship here. Oops, I mean, not that one. There we go. So can you name the type of angles that are in question or being described? Okay. So I would say, as always, I would, I want you to try it on your own and then see if your stuff matches the answers. If you just copy stuff, you're just not going to get anywhere. You just got to try it. So like this, that's part of the activity today. You need to pause it and then try it on your own and then verify that you get them right. So don't just watch me do it. Pause it, and then now watch do it. Okay. All right. Hopefully you've done it. Don't just copy. All right. 4 and 9. I know those are same side. Interior. Okay. 1, that's where you need to be. You need to see them. And you're like, okay, 1 and 11. Oh yeah, those are alternate exterior. Okay. 2 and 10. Those are on the top right corners. So I'd say they're matching. So I'd say corresponding. We're just trying to name them. If you didn't practice on your own, I feel sorry for you. 3 and 9, those are switching on the inside. So I'd say alternate interior. Yes, write the whole thing out. Do not try to abbreviate it if you're trying to shorthand these things. Don't do it. 12 and 3. Okay, I don't think that's a relationship we talked about, right? One's on the outside, one's on the inside. They are switching. Some might even call them, what did they say? I don't know. Sometimes they have a name for that, but there's no name. We have no relationship here. None. Okay, we didn't talk about anything like that. Classify the pairs. There you go. Okay. Or I guess I should have put neither, since it said in the directions neither, but same idea. Okay, and now you have another set. So you have to be careful on where the transversal is versus your 2 lines in question. So I'll give you the example and then you pause it. I'd say 4 and 8. Which line do they both touch? I would say they both touch this line. So that's your transversal, and these are your 2 lines in question. Now this could change based off of what angles you're choosing, but if I'm looking at this based off that transversal, I'd say they're both in the bottom left-hand corner, so I'd say corresponding. You will run into a question that has many lines like this, like 4 of them at least. So you're gonna have to decrypt that code of what's the transversal. That would be this one, obviously. And then where are the 2 lines that we're wanting, and then answer the question that way. All right, try this without looking at my answers before. All right, I'll try to do them all though with the highlighting the transversal. 3 and 11, hopefully you paused it by now. I see that they're both touching this line. That's my transversal. Here are your 2 lines in question, both in the bottom right. I'd say corresponding again. Let's make it easy on us. 2 in a row. All right. I'd say, let's see, 12 and 5. Okay, here's the problem with this. Look at this. This one, you can't get a transversal that touches both of them. So you might have said something like weirdly alternate exterior angles or something. That is definitely not true because they're not touching a transversal. I'd say actually neither. Freaky. Okay, that's it. That's the answer. 9 and 15. Okay. Well, which is the line they both are touching, right? Which is the one where they're both on. I'd say they're both on this one, clearly. And let's see, you could also, if you wanted to mark anything else, like they're on the outs, right? This would be the inside between them, but they're both on the outside and they're alternating, they're switching. So I'd say alternate exterior. Okay. And last one, 2 and 5. Yeah, you can see that they're on the inside, and here's your transversal. So that's same side interior. So that's how fast you need to get if you're not quite that speedy. That's fine for now, but you do need to get faster at these things. All right, so that's kind of the main piece of the puzzle of the day. We're going to do a thin slice on Friday for sure, but let's see if we can pound some notes then when I get there. Maybe I answer just a few questions and then run that ship. But that's the goal. Like if you needed to end this, and I don't know how much time this is taking, and the class is over, that's fine. And then you can maybe start some of these. No, you probably can't do too much. Okay, so let me then show you a little bit why the heck did we do that? We are naming them to then relate these two lines, because we said these lines are going to intersect at some point. We know if, here comes the like geometry vocabulary of conditional statement. If the corresponding angles are congruent, then the lines are parallel. And I'm going to use that little symbol just to make your life a little quicker. Nice. If the corresponding angles, let's pick a set. Let's go something different. Let's go corresponding angles. Right? I probably should have said if the transversal, if you have 2 lines and a transversal that create corresponding angles and those are congruent. But I'm just going to say if corresponding angles are congruent, then you know that the lines are parallel. So these, let's just call them 20 and 20 or something like that. If you know those are the same, then you can say that these lines are parallel. That's where we're going to be going with this and all these. We're going to see the relationship, see what their angle measures are, and determine, are those lines parallel? And you'll say yes or no. If this was 20 and this was like 50, you'd be like, no, those aren't parallel because the corresponding angles are not congruent. That's the whole like 2.1 to 2.3. Can you determine if these angle relationships are the same or, however they're related? Most of them are going to be congruent, but you have to determine, hey, that's like your 3B reasoning. Hey, they're not the same, so they're not parallel, things like that. So there's a lot of different things that we're talking about. We're talking about angles, and we're talking about lines that are parallel. People mix the two up a little bit, so we'll keep talking about it. All right, let me stop, Bab. I'm going to keep going here. Alternate interior angles. If alternate interior angles are congruent, then the lines are parallel. Now, notice I didn't say the same. This means the same. This means, let me maybe put this. This means face the same direction. This is a very important distinction because you'll say the same and you'll be wrong. These lines are not the same. They're facing the same direction. That's what parallel lines are about, direction. If they're the same line, then you just have two lines that are just on top of each other. That's not it. But you could say that angles are congruent. We just said 20 degrees and 20 degrees. Same measures. Something in that like area. You need to know, I promise you, some people will get this wrong. You need to know the difference between these two things. I hope to make that very clear in our time. Anyways, let's go here and here. Let's say this is 50. If this is also 50, you can say that these lines are parallel with this transversal in the middle here. All right, lots to be said. We'll keep going. If, this is very redundant, but we're still running here, alternate exterior angles are congruent, then the lines are parallel. Again, facing the same direction. So let's find them. Let's say there's a great one, there's a great one, here's 110. If this is 110, then you know these are parallel. Very important that I highlighted over there. Same side interior. This one is the one that's not going to be congruent. Ooh. Let's go that color. Same side interior. Same side interior. Ooh, different markings. If the same side interior angles are, here we go, supplementary. Supplementary means, hopefully you remember, that's why we introduced that word. Two angles that add to 180 degrees, right? These will be two angles, a pair of angles that add to 180. So, see if I can change the color of this. Ooh. let's say this is 50, this would have to be 100. Oh, let's try that again. A little more to scale. This is 130, this is 50. Like, if that's true, then the lines are, you guessed it, parallel. Right, and that would make sense because if this is a flat line, right, truly a straight angle, if this is 50, then the other side must be 130. Oh, alternate interior angle. So it's just a kind of quicker way to relate things. You don't have to like work for your corresponding angles either. Like this would be 50 also, right? Up here, which your corresponding angles are here. Corresponding angles are congruent, and we know they're parallel then, the lines. So you don't need to write all that, but they all can relate to each other in some way. But that's kind of a good understanding of what we're doing. All right, here's the last two, and you have to be mindful. This means that they're going to be parallel. 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 Vertical angles, if you located them, hey, that's not touching this other line in question here from the transversal, right? So we don't know anything about this intersection. We know if, what do we want to say with this actually? If the lines intersect, then yeah, I would say if if two lines intersect, then vertical angles are congruent. Vertical angles do not prove parallel lines, right? It doesn't even make sense. So if they're trying to get you to use vertical angles to prove parallel lines, no, that's so wrong. Let's go 60. This is 60 then, right? You don't know anything about this line. You can't say like this is 60 over here, right? If that's all they give you, you got to pay attention to what they're providing you. And then same goes for linear pair. Like that's not proving parallel lines. We said linear pairs will be on one line and they will add up to 180, right? So if two lines, intersect, then linear pairs are supplementary. Okay, so this one does not also prove, this one does not also prove parallel lines. You just have some like supplementary angles, or you have some congruent angles. Okay, well, I don't know how much time is left in the class, but I would say you start maybe some of this to kind of see what we're doing. If you don't have time, if you have like 2 minutes left, then just stop and get out of here. But if you have like 10 minutes left or somewhere in that 7 to 10 range, then see if what you can do in terms of describing them and then running that ship there. I'll try to re-emphasize some of the points, but I put some really important pieces thrown at you, and we just got to play the game tomorrow of thin slicing practice with some people. All right, thanks for watching, listening. Hopefully you took some good notes, and I will see you next time. All right, peace.